Okay, we are going to perform the simplex algorithm for the first problem of chapter 3. Now, the first thing to do is introduce the select variables. We're going to have one select variable for each constraint. And so that will be 2x1 plus 5x2 plus x3, which is our slack variable, equals 12. And then we're going to have x2 plus x4 is equal to 2, where x3 and x4 are the slack variables. Now, since when performing the simplex algorithm, we start from the origin and then move to the other corners of the feasible region, we need to have z minus x1 minus 2x2 equals 0. So we write the objective function as a function which is equal to 0. And now we can input the coefficients of these equations into our tableau. So we're going to have x1, x2, x3, and x4. This is where we put the basic variables. And these are the resource values. So we have 2, 5, 1, 0, and 12, and 0, 1, 0, 1, and 2. And then z, minus 1, minus 2, 0, 0, 0. And we can see that the first basic variable is x3, so we put x3 here, and the second one is x4. Since they have a 1 entry and the rest of the column is zeros. Now, we need to choose the entering basic variable and the departing basic variable. In order to choose the entering basic variable, we need to go to the last row of z, and we need to pick the smallest entry, which we are going to call, for convenience, the biggest negative entry. And that is minus 2 in our case. So that means, since minus 2 is in the column of x2, that x2 will be our entering basic variable. And now we need to choose the smallest ratio of the resource values over the coefficients from the column x2. So here we're going to have 12 over 5, and this is going to be 2 over 1. And we can see that the smallest ratio is 2 over 1, so we're going to pivot on this element, and so we can see that x4 is going to be our departing basic variable. So we're going to have x3, which stays a basic variable, and then x2 will be our entering basic variable, and we still have z here. Now, we can see that the entry we're going to pivot on is 1, and we wanted a 1 in that place anyways, so we're going to write this row exactly as it is. And now we need to create zeros in the column of x2 for the other rows. So what we do is we subtract 5 times the second row from the first row over here. So we're going to have 2 minus 5 times 0 is 2, 5 minus 5 is 0, 1 minus 5 times 0 is just 1, 0 minus 5 times 1 is minus 5, and 12 minus 5 times 2 is just 2. And now for the last row, we need a 0 where minus 2 is. We're going to add in the z row 2 times the second row, this row of x2. So minus 1 plus 2 times 0 is just minus 1. Minus 2 plus 2 is 0. 0 plus 2 times 0 is 0. 0 plus 2 times 1 is 2. and 0 plus 2 times 2 is equal to 4. And now we're going to perform the simplex algorithm again until we have no negative entries in the Z row. We can see now that we have a -1 in the first column of x1. So x1 is going to be our entering basic variable. So we're going to have x1 here, and then x2 stays, and then z. So we can see now that we cannot divide with 0. So the ratio, the smallest ratio is going to be 2/2, which is 1, and we're going to pivot on that element. And since we want 1 in that place, we're going to divide the whole row with 2. So we're going to have 1, 0, a half, minus 5 on 2, and 1. Now the next one, we want it to be 0 in that column, and it is a 0 already, so we're going to leave this row exactly as it is. And now for the other one, we can just add the Z row with the new X1 row that we have there. So this is going to be 0, 0, a half. 2 plus minus 5 on 2 is minus a half. And this is 5. We can see that we still have a negative entry in the Z row. This time our negative entry is in the column of X4. So we can see that X4 is going to be our entering basic variable. And since in that column we have a negative entry, then this is the element we can pivot on. So X2 will be the departing basic variable. So we have X1 and X4 and then Z. We can see that the entry here is 1, and this is what we want, so we're going to leave this row exactly as it is. Okay, now we need to make the other entries of this column to be equal to 0. So we're going to add into this row 5 on 2 times this row. So we're going to have 1 plus 5 on 2 times 0 is 1. 0 plus 5 on 2 times 1 is 5 on 2. A half plus 5 on 2 times 0 is just a half. Minus 5 on 2 plus 5 on 2 is 0. And 1 plus 5 on 2 times 2 is just 6. And now we're going to do the same with the last row. So we're going to add in the last row a half of this row. So we have 0, 0 plus a half is a half plus 0 is a half, this is 0, and this is 6. We can see that we have no negative entries in the Z row anymore, so we can stop the simplex algorithm now, and we can find the optimal solution. So the optimal solution occurs at, so we have 1 here and 0, so x1 is a basic variable, and we can go and see what x1 is. x1 is 6. x2 is not a basic variable, so it is 0. The same with x3 is 0, and x4 as a basic variable is equal to 2. This is the corner 0, 6, which we were expecting, with z equals 6. And we can also do a quick check. So for x1, x2 equals 6, 0, we have that z equals x1 plus 2 times x2, so this is 6. So we can see that our optimal solution is correct. And that is it.